Starting with the input mn, machine A gives an output of nm. Starting with the input mn, machine B gives the output m plus 3n n. Starting with the input mn, machine C gives the output m minus 2n n. Natalie starts with the pair 0, 1 and inputs into one of the machines. She takes the output and inputs it into any one of the machines. She continues to take the output and receives and inputs it into any of the machines. For example, starting with 0, 1, she could use machines B, B, A, C, B in that order to obtain the output 7, 6. Which of the following pairs is impossible for her to obtain after repeating this process any number of times? Let's start with the pair that they have given us, and let's just see what it looks like. When you put it through A, obviously it just flips. If you put this through B, it will become 3, 1, where this is the formula m plus 3n, n. And if you put this through C, it will become minus 2, 1, m minus 2n, n. And do you see any kind of pattern? Not really, right? You say, well, I have no idea. This doesn't really help me. So 0, 1 is not really going to be very beneficial to try to look for any kind of scenario. So what I'm going to do is choose something else. And you can choose anything, and it should work for anything of what I'm trying to show. I'm going to choose 3, 6 for my initial mn. And let's see what happens. Now, what we are really interested in talking about is something called the GCF, greatest common factor. And in this case, the greatest common factor for 3 and 6 is 3. And you will see that all the outputs will also have a greatest common factor of 3. So let's first figure out the outputs. A was just going to be 6, 3. So I think that's pretty obvious. But what about if I go through this machine? That gives me 21 and 6. And if I go through C, it gives me minus 9 and 6. And I hope you're convinced that all the outputs also have a GCF of 3. So that is the key to the question, basically, that the greatest common factor will be maintained as you go through these machines, no matter what the original pair is. So now we go back to our question, which is 0, 1. What is the GCF of 0, 1? Well, it's just 1. Unfortunately, it's that simple or boring, because the greatest common factor of 0 and 1 is 1. The factor of 1 is just 1. And 0, well, anything is a factor of 0, right? So the GCF here is 1. So what we are asked to do is somehow eventually come up with one of these, right? So that means that anything you come up with will also have to have a GCF of 1. So whatever, it doesn't matter what order, how many times you do it, multiple times over, at the very end, whatever you come up with also must have a GCF of 1. So then we have to now look at the answer choices. Which one of these has a GCF of 1? Okay, to do that, we've got to look at each number. So fortunately, there's not too many. There's only 5 plus 1, 6 numbers we have to look at. So the first one, 2009, and if we break that up into prime factors, it's 7 times 7 times 41. The next one is going to be 1016, and that is 2 times 2 times 2 times 127. This is the prime factors. Next one is 1004. That is 2 times 2 times 251 as its prime factors. 1002 in the answer choices. 2 times 3 times 167. Then 1008. That is 2 times 2 times 2 times 2 times 3 times 3 times 7. And last one is 1032, and that is 2 times 2 times 2 times 3 times 43. So that is the common factors of everything. Well, that is the factors of everything, not the common factors. Okay, now we have to now compare everything with 2009. Keeping in mind, do we have a GCF of 1? And if you do compare any of these 5 numbers with 2009, you'll notice that all of them have a GCF of 1 with 2009, except 1008. Because 1008 has a GCF of 7. So that means that since it has a GCF of 7, 1008 and 2009, it cannot go here as an output. Why? Because you're starting with 0, 1. The output must have a GCF of 1. If you put 2008 and 2009 and 1008 here, that won't work because these two have a GCF of 7. And there's no way to get a GCF of 7 if you're starting with 0, 1, because the GCF is maintained throughout this process. So that is the only one that is not possible. All the other ones can be placed in there as an output. So number 24, the answer is D. Anne and Brenda play a game which begins with a pile of N toothpicks. They alternate turns, with Anne going first. On each player's turn, she must remove 1, 3, or 4 toothpicks from the pile. The player who removes the last toothpick wins the game. For which of the following values of N does Brenda have a winning strategy? In a game, a player has a winning strategy if, regardless of what the other player does, there are moves that she can make which guarantee that she will win. So this question is going to involve casework. We're going to have to start with N equals 1. And we are going to have to keep doing that. N equals 2, N equals 3, so on. And hopefully get some sort of a pattern. And if we do, we can extrapolate that pattern and figure out which one of these numbers guarantees a win for Brenda. All right, for N equals 1, remember Anne goes first. So if Anne goes first, all she has to do is just remove 1, and she wins the game. So what I'm going to do is I'm going to write the number here that she has to remove, and in brackets I'll write how much is left over. And if 0 is left over, that means the person wins the game. Okay? And this is Anne, and this is Brenda. So we started with 1, right? N equals 1. She removes 1, and there's 0 left over, so she wins the game. So Anne wins. Now, what I'm going to do on the side here is that for every value of N, I'm going to write who won. Did Anne win or did Brenda win? So we'll just make a table on the side. So when N equals 1, it's Anne that wins. All right? So this is our system, what we're going to use. N equals 2. For N equals 2, let's say Anne chooses 1. That's the only thing she can do, because she can only remove, remember, 1, 3, or 4. Those are the only choices that she has. Those are the only choices Brenda has also. So the only thing she can do is remove 1. If she does remove 1, there's 1 remaining. Okay, that's what I'm doing in this question. I'm putting what's remaining in the brackets. If there's 1 remaining, Brenda just removes that. And there's 0 then remaining, and Brenda wins. So for N equals 2, Brenda wins. All right, so far so good. Following, nothing confusing so far, hopefully. N equals 3. Well, again, Brenda doesn't even get a chance in this scenario because Anne, is that her name? Yeah, Anne just removes 3, which she's perfectly allowed to do. There's 0 left, she wins. Boom. So Ann wins when n is equal to 3. N equals 4. The exact same story. Brenda doesn't even get a chance to play because Ann just immediately removes 4. There's 0 left, and she wins. So n equals 4. Ann wins again. N equals 5. Who wins when n equals 5? Okay, well, we just got to think about this. What Ann can do is she can remove 3. That's the strategy. Why? Because if she removes 3, there's 2 left. And when there's only 2 left, Brenda has only one choice, which is to remove 1. And then when she does, there'll be 1 left. It'll go back to Ann. It'll be Ann's turn again. And then since there's only 1 left, she removes it. And there's 0 left, and then she wins. So this was the strategy there. So n equals 5, Ann wins again. So see how I'm doing this? So unfortunately, this is one of those time drain questions. You got to do this for, I don't know how long this is going to go on for, but unfortunately, this is what we have to do. Unless you have a magical way of figuring this out. If you do, please, put it in the comment section. N equals 6. Well, again, Ann can use the same kind of strategy. Remove 4, meaning there's 2 left. That leaves Ann as a potential winner because Brenda can only now remove 1. When she does, there's 1 left. The turn goes back to Ann. She removes that and wins. There you go. N equals 6. Ann wins again. Now n equals 7. When n equals 7, we got a few scenarios, right? When Ann removes 4, there'll be 3 left. If there's 3 left, then Brenda can just remove those 3 and she wins. But we got to think about other scenarios too. That's just one scenario. If n equals 7 and Ann removes 3, there's 4 left. But Brenda can remove those 4 and win that way. Now what about on the first move if Ann only removed 1? If that's the case, there would be 6 left. And if there's 6 left, then Brenda is going to try to win. How does she win? Well, by removing 4. That leaves 2. And the turn goes back to Ann. She can only remove 1. That leaves 1. And then Brenda just removes that 1 to get 0. So in all scenarios for n equals 7, Brenda wins. So finally we got a check mark for Brenda. All right? I'm just going to do a couple more because I think you get the point here. You get the kind of the way of doing it here. I'm just going to do n equals 8 and n equals 9, and then we'll talk about this. Okay, so who's going to win for n equals 8? We got Ann and Brenda here. All right, well, if Ann removes 4, there's 4 left. Brenda can just remove those 4 and win. So that's the first scenario. If Ann removes only 3, there's 5 left. Then Brenda can remove 3, and that leaves 2. Then Ann can just remove 1. That's the only choice she has. That leaves 1. And Brenda removes that and wins. So it looks like so far Brenda is going to win. But Ann is smart. She's going to try to choose a strategy to make Brenda lose when n equals 8. So how does she do that? Well, she does the following. She removes only 1, and that leaves 7. And then if Brenda removes now 3, it will result in 4. So then, Ann can remove those 4 and win. So then Brenda thinks, okay, that's no good. I don't want to do that. Let me remove 4. If she removes 4, there's 3. So Ann can just remove those 3 and win. So then Brenda thinks, okay, my only hope is to only remove 1. And therefore that will leave 6. Okay, well, Brenda's still in the game here. Then it goes back to Ann. Ann says, okay, no problem. What I'll do here is I'll remove 4. I'll remove 4 from those 6. That leaves 2. Brenda can only now remove 1. There's 1. And then Anne removes that 1 to win. So Anne will play this in a way to win. You see what I mean? So therefore, for n equals 8, she wins. The only way that Anne can lose is if all the scenarios she loses. See what I mean? And that happened here when n equals 7. It also happened when n equals 2. And then one last one, n equals 9, and then we'll discuss this. Okay, so we've got 9, right? So if Anne chooses 4, removes 4, there's 5 left. Brenda is just going to say, okay, I'll just choose 3 to make 2 left. That way Anne can only remove 1. That leaves 1. Then Brenda just removes that 1 and there's 0 left. She wins. Okay. So Anne is obviously not going to use that strategy. Let's try a different strategy. She'll remove 3. 6 left. Brenda says, okay, no problem. I'll remove 4. 2 left. Anne can only now remove 1. 1 left. And Brenda removes that last one to leave 0, and she wins. All right, only one strategy left, right? And that is to only remove 1. So Anne removes 1. There's 8 left. Correct? Brenda says, okay, let me remove 3. I'm not really sure here. It's 5 left. Anne removes 3, leaving 2. Brenda can only remove 1, leaving 1. And then Anne removes that 1 to leave 0, and then she wins. So this is discouraging. So Brenda thinks, oh boy, this obviously is no good. I didn't win when n equals 9. But don't worry, there is a way for Brenda to win. And it's as follows. We'll go back to this scenario. Anne starts off by choosing 1, 8 left. Brenda decides, okay, you know what, I'm only going to remove 1 this time. And if I remove only 1, there's going to be 7 left. Goes back to Anne. She's going to play a cat and mouse game. Only remove 1. 6 left. Brenda thinks, okay, I think I'm going to beat you. I'm going to remove 4. There's 2 left. Anne has only one choice to remove 1. There's 1 left. And guess what? There's 1 left. Brenda removes it. 0 left. And Brenda wins. So for 9, after all that hard work, Brenda wins. So this is basically the pattern. As you can see, you can probably do this on your own. Keep doing this. And if you do, you will get a certain pattern, right? And here's the pattern that we figured out in our trial and error system. And I put B's in below the n numbers that Brenda wins. So it was 2, 7, and 9. And in general, Brenda will have a winning strategy for n, and n minus 1, n minus 3, and n minus 4 will be the winning strategy for Anne. All right, and I'll let you do all the rest. I certainly don't think you want to hear me go through every single one. And very quickly, if you extrapolate this, you'll get a list for Brenda as follows: 2, 7, 9, 14, 16, 21, 23, 28, 30, 35, and so on. And of the answer choices, the one that is in this list is 35. So, number 24, the answer is E. Six players compete in a chess tournament. Each player plays exactly 2 games against every other player. In each game, the winning player earns 1 point and the losing player earns 0 points. If the game ends in a draw, each player earns half a point. What is the minimum possible number of points that a player needs to earn in order to guarantee that he has more points than every other player? Well, let's see here. Each player plays exactly 2 games against every other player. So there's 6 players, so each player, let's say A, B, C, D, E, and F represent the players. Each player is going to play the other 5 players twice, so each player plays 10 games. 10 games per player. So what we have to do is create some scenarios, see if, looking at the answer choices, which one of these work and which one of these don't. And I guess take it from there. So let's do that. So let's start off with A, B, C, D, E, and F, and let's try to make somebody have 10 points, and let's see if that guarantees that he will have more points than everybody else. If he has 10 points, that means he got those with 10 wins. 10 wins, 0 draws, 0 losses, right? So the number of points for player A is 10. If he had 10 wins, then that means there was 10 losses, right? Every game that he won, somebody lost. So we have to distribute them evenly. So 2L, 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 like that. Because he won every game he played. So every single game the other players played against him, they lost. So that's why it's 2L like that. Okay, now let's talk about B. If B lost 2, let's say he won the other 8. So we have to now distribute those 8 losses that the other teams had among the other 4 players. So we can distribute them evenly, 2L, 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 like that. Same sort of scenario. If C lost 4 games, then let's say he won 6 games. We have to distribute those 6 losses to the other teams. So 2L, 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 and 2L. D lost 6, so 1, 4. Distribute those 4 losses evenly among the other 2. E finally lost 8, 1, 2. And we distribute those to F, which would be 0 wins. Now let's tally up the points. The points looks like 0, 2, 4, 6, 8, and 10. So without a doubt, if a person scores 10 points, he's guaranteed to have more points than any other player. So this is fine. But we want to see if any of these can also guarantee. All right, no problem. Let's keep that in the screen and let's do the exact same scenario. This time for 9.5. And let's see what we get. Since the next answer choice is 9.5, we want to try to see if a scenario of 9.5 can guarantee a situation where one player has more than every other player in terms of points. Well, a 9.5 will be obtained if you have 9 wins and 1 draw, because you will get 9 points for the wins and a half a point for the draw. So that would give you 9.5 points. Now we have to now start thinking about all the other guys. Okay, well, if we distribute the draw to the very next player, right, because if he drew one game, then he had to tie with another. So that draw has to match with some other player. Let's just say it's with B. And then now let's proceed pretty much in a simple way. If this guy has a draw, he can't have 9W, 0 losses. He can, but if that's the case, it'll be 9.5. And that's the same. We want a scenario where A has more points than every other player. Okay, so that's no good. We don't want to give 9 wins. So let's give 8 wins. And also what's very important to mention is that even if you tried to give 9 wins there, it wouldn't work, because when you distribute the 9 matching losses, you have to distribute them evenly. And if you did 2L, 2L like that, this is now 12 games. And remember, a player only plays 10 games. If you distribute them evenly like 2L, 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 and 1L, you're still 11 games. So that's another very important thing to illustrate, that even if you wanted to, you couldn't put 9W. So you have to put 8W in order to make things match. 8W works with one draw, but remember that only accounts for 9 games. So that means there had to have been one loss here. So the other 8 losses for matching player A's 9 wins have to go here. 2 losses, 2 losses, 2 losses, 2 losses. Okay? Now we have to account for those 8 wins and the matching losses. So we can distribute them evenly. 2 losses, 2 losses, 2 losses, like that. C, let's just keep it simple and say he lost 4, so he won 6. Distribute those 6 losses. D lost 6, so won 4. Distribute those 4 matching losses. E lost 8, that means he won 2. Distribute those 2 losses, and then that means F has 0 wins. So the points will be as follows. We have 9.5 as previously calculated. Here will be 8.5, and then the rest will be 6, 4, 2, and 0. So this is a scenario that clearly guarantees that 9.5 for A is greater than every other. But it actually doesn't guarantee it 100% because I have to create other scenarios. Now, the first scenario is right here. Another scenario I'll do, and then later I encourage you to see if there's any other scenario that you can create that negates this, but you won't be able to, because you won't be able to get any scenario that matches up like I did with the 9 wins here. You remember? It created a scenario where you couldn't get 10 games. It would be either 11 games or 12 games, and it wouldn't work. Another way is if you have 9 wins, 1 draw, 0 losses, but instead of putting the draw here, I'll put the draw way out with another player. So let's say I'll put the draw with F, 1 draw here. And then I will give this guy 8 wins, but I'll give him 0 draws. And then I have to now distribute those 2 losses. 9 losses, I should say. So here we go. So we'll do 2 losses, 2 losses, 2 losses, 2 losses, 1 loss. But that's pretty much the same thing as this. I just interchanged B and F. So let's make it a little bit different than that. Let's put 1 loss here and 2 losses there. That makes a little bit different. Okay, so we accounted for those 9. How about these 8? We have to write 8 losses now. So 2L, 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 2L. That means if this is 4, we can make that 6W, account for 2 losses each to make that 6 losses. This D now has 6 losses, so 4 wins. Account for those 4 losses. This is now 7 losses, so 3 wins. We have to account for 3 losses. So the only guy I can put is there, but the problem here is now this overcounts. We have 12 games and F is only allowed 10. So as you can see, it doesn't match. So the only way to make it match is to have a scenario like this. So in a very thorough way, I hope I have illustrated that this is sort of the only way of doing it, and therefore it guarantees that with a score of 9.5, a player will have more than every other player. Okay, so this is also good. So now we have to see about 9. Now let's see with 9, A, B, C, D, E, and F. Okay, the only way to get 9 points, or one way to get 9 points, is to have 8 wins and 2 draws. And when you do that, you now have to, in the same way, account for the 2 draws with some other player. So if player A played 2 games and both games were draws, there was another team that also drawed with him, or another player, I should say. So that means that we'll make B the player that he tied with both times. So in a very similar way, this has got to be equal to 8. But before we put that in, let's account for the losses. Now, he already played B twice, so he didn't lose to B. He tied with B twice. So no losses can go here, accounting for these. So the other losses have to be distributed among the other players. So that means that since there's 0 losses here, this was 8W. Now these 8 wins, we have to account for those via losses. So we put 2L, 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 2L like that. Here's 4 losses, 6 wins that means, so account for those with the other players. Here 6 losses, that means 4 wins, account for those. Here E, 8 losses, 2 wins, account for those. And this is 0 wins. So let's see what the totals are now. This is 9, this is 9, this is 6, 4, 2, and 0. Well, now we have to discuss this. What we found is a scenario that works, meaning everybody plays 10 games. There's no overcount, there's no 11 games, 12 games, that kind of problem. But notice, even though A has 9, he doesn't have more than every other player. He actually has the same as B. So this is where we have to start discussing this question. Basically what that means is that since we found a scenario where having 9 points does not guarantee that a player has more points than all the others, 9 points does not guarantee that a player will have more points than any other player. So that scenario basically shows that having 9 points does not guarantee that a player has more points than all the other players. This scenario is a perfectly valid scenario because all the players have played 10 games, and when I calculated the points, as you can see, 9 points is obtained by player A, but it's also obtained by player B. So we are now concluding this question. As I've shown above, if a player has 10 points, which was shown here, or has 9.5 points, it is guaranteed that that player will have more points than all the others. But if he has 9 points, like here, it is not guaranteed. So to repeat, as shown above, if a player has 9.5 or 10 points, it is guaranteed that he or she will have more points than all the other players. But if a player has 9 points, it is not guaranteed. So that means the minimum number of points that are guarantees a player to have more points than all the others is 9.5, which would be right here. And that is the final part of the question. Therefore, the minimum number of points that guarantees having more points than all the other players is 9.5. And therefore, the answer to number 22 is D. In the diagram, a 4x4 grid is to be filled so that each of the digits 1, 2, 3, 4 appears in each row and each column. The 4x4 grid is divided into 4 smaller 2x2 squares. Each of these 2x2 squares is also to contain each of the digits 1, 2, 3, 4. What digit replaces P? Alright, so we got to fiddle around with this. Okay, so first and foremost, we have 1, 2, 3, 4 already written for us. So that means that the 4 cannot go here, right? Because the 4 is already in this column. So the 4 must go here. And then the only other number in that row that's missing is the 2. All right, so that's the first step. Then in this one, 1, 2, 3, 4 have to appear. So the only one that's not there is 3. So 3 goes there. All right, so far so good. And then we have to now look at this row right here. It already has a 3 and a 2, so what is missing is 1 and a 4. The 4 cannot go here because the 4 is already here. So the 4 must go here. And then therefore the 1 has to go there. Now at this point, this column has everything except the 3, so the 3 must go there. So far so good. Now at this point we have a few choices, right? We can put either in these two 2 and a 1, but we're not sure where the 2 goes, where the 1 goes. So we take a chance, we put a 2 here. If it doesn't work, we can always go back and start later. So let me use a different color so I know where to start back if I make a mistake. 2 goes there. Therefore, by process of elimination, the 1 must go there. Now we're left with the last box. In this row, we need a 4 and a 1 since we have a 2 and a 3 already. The 4 cannot go here since the 4 is up here. Can't be in the same column. So the 4 must go there. And therefore the 1 must go here. And to finish this all off, the 2 goes here, obviously, and the 3 goes here. So everything works out. So the P is equivalent to a 1. So 22, the answer is 8. Steve placed a counter at 0 on the diagram. On his first move, he moves the counter 1 to the power of 1 step clockwise to 1. On his second move, he moves 2 to the power of 2 steps clockwise to 5. On his third move, he moves 3 to the power of 3 steps clockwise to 2. He continues in this manner, moving n to the power of n steps clockwise on his nth move. At which position will the counter be after 1, 2, 3, 4 moves? This question basically is saying that first you have 1 to the power of 1, then you have 2 to the power of 2, then you have 3 to the power of 3, and then so on, right? 4 to the power of 4. And then eventually you're going to get to the very last one, which is 1, 2, 3, 4 to the power of 1, 2, 3, 4. And this, mathematically, is represented with a summation. And I'm sure you have seen this. If you haven't, it's okay. It's from 1 to 1, 2, 3, 4 in this particular case, of n to the power of n. That's how you would represent it. Now, what they're saying is that this huge number, if you were to calculate it, and then you count from 0, eventually you would end up at one of these numbers. Okay? So they give you a few examples to kind of help you out. They say, okay, in the very first move, it's 1 to the 1, which is equal to 1. You're starting here. If you go 1, you end up here. Then you move 2 to the power of 2 steps, which is equal to 4. So you move 4 steps. So 1, 2, 3, 4. You end up here. Then you move 3 to the power of 3 steps, which is equal to 27. So I'm going to go 27 times. But the good news is that because there's only 10, I can just sort of count by tens. If I go 10 around, I end up back right here. Another 10, I end up back there. And I have to move another 7, right? Because it was 27, 3 to the power of 3. So I really have to just move 7. 1, 2, 3, 4, 5, 6, 7. And that's exactly what they're saying. So that is how you figure this out. So what we have to do is make a table. And in my humble opinion, this question is easy if you have a calculator. And the good news is that on the Canadian math contests, which is what this is, a calculator is allowed. The only thing is that in this particular question, you will get to a number that is so large that generally speaking, most calculators will not be able to calculate it. But there is some good news, and I'll talk about that once I get to that number. So here we go. Let's make a table and begin. This is my move. This is my value. This is my cumulative sum. And this is my position. Position. I have to squeeze it in there. So the first few are pretty easy. That's the good news. 1 to the 1, 2 to the 1, 3 to the 1. Those are the ones they give you. But be careful, like I made a mistake there. It's 2 to the 2, 3 to the 3, right? And then you kind of keep on going, 4 to the 4, and so on. The value, 1 to the 1 is 1. That means the sum so far is 1, position is 1. And these ones they gave you in the question, right? We don't need to worry about those. Same thing with the second one. The value is 4. This cumulative sum is 5. The position is 5. 3 to the power of 3, that is 27. Cumulative sum is 32. And remember, just divide by 10. That's a trick in this question. Take that number and divide by 10, and the remainder will be your position. So for example, for 32, because it's 10 all the way around, 10 positions, divide by 10, you end up back here. That's the start. You end up back at the start. The remainder will tell you the position. So with 32, the remainder is 2. So that goes there. So that's definitely going to help us. We don't need to worry so much about trying to count, which would be ridiculous. We can just take this sum and divide by 10, and whatever the remainder is, that will be our position. Let's go 4 to the power of 4. Numbers will start to get a little big here. 256. Cumulative sum is 288. Position, remember, divide by 10 and get the remainder, and that's 8. Now, I'm hoping to see a pattern here, right? Because any kind of question like this, we're obviously not going to go till 1, 2, 3, 4 to the power of 1, 2, 3, 4. We want to see some sort of a pattern. If we can get it, we can extrapolate. So 5 to the power of 5. And like I said, this question, because you're allowed to use a calculator, you can figure these numbers out pretty quickly. And it's not really that big of a deal. 3, 4, 1, 3. Well, again, the remainder would be 3 if I divide 3, 4, 1, 3 by 10. Let's just keep going here. I'll do a few more and then I'll fill out all the numbers because I don't think you really need to hear me fill out every single one. These numbers, I have to squeeze them in, so I'm not going to be able to write them all in one line, but that's okay. 50069. It's a 5-digit number. And that position will be 9. 7 to the power of 7. That is 8, 2, 3, 5, 4, 3. The cumulative sum so far will be 8, 7, 3. 6, 1, 2. And therefore, if you divide by 10, the remainder is 2. And you just keep going like this. And at this point, I still don't have a pattern because I got 283, but then I got 287. Well, that's a bummer. Well, keep going. And like I said, if you have a calculator, which you're definitely allowed to use, this is no problem. The only time it becomes a problem is when I get here, 14 to the power of 14. I don't know what calculator you're using. I just use the calculator on my phone, right? That tends to be the norm nowadays. And my phone does allow me to go up till 13 to the power of 13. After that, if I try to do this guy, 14 to the power of 14, it gives me that E, which means that it's too large. But I'll show you what you can do with 14 to the power of 14. Let me just fill in all of these first. So now at this point, this is so far just basic addition. Yeah, the numbers are large, but that's not a big deal, right? I mean, you guys are smart. But now the problem is that when you get to 14 to the power of 14, most calculators don't go that high. If you have a calculator that does, then this is a breeze. You can just continue. So what do? Do you manually figure out 14 to the power of 14? And the answer is that's the only thing you can do, right? Because you have to figure out some sort of a pattern. So far, we don't have any. The good news is that you can break up 14 to the power of 14 into 14 to the power of 7 times 14 to the power of 7. And these numbers you can do in your calculator, right? You can easily spit this out. 105, 413, 504. And unfortunately, if you multiply these two, you'll get that E, right? It doesn't show. But you can do this manually. Yeah, it'll take you a little bit of time, but the good news is that when you do, you will see something very cool. And that is the following, that 14 to the power of 14 ends in 0, 0, 0. Okay? It's some big long number, but it ends in 0, 0, 0. So when you add that number, big long number, when you add it to this cumulative sum, the sum will end in 437. So I hope you can see that. I'll just write out the full number. And that means the position is 7. And very similarly, when you do 15 to the power of 15, you say, well, my calculator can't do that, but you can break it up into 15 to the power of 8 and 15 to the power of 7. And your calculator will give you values for these guys. And you can manually do this. It takes a little bit of time, but it's the last question of the contest. Of course, it's going to take time. But the good news is that when you do this, you'll quickly be able to realize that, again, the last 3 digits of that is 0. So when you take this big long number, whatever it is, and add it to this, again, the last 3 digits will be 437, and again, you'll have a 7. So, and then it just keeps going like that. If you have 16 to the power of 16, that number also has 000 as its last 3 digits. Same story. When you take that number, add it to this number, the last 3 digits will be 437, therefore the position will be 7. So it's always going to be 7 now. So I hope you can see that it's, in my opinion, with a calculator up until this point, it's just a piece of cake, right? It's just adding numbers. Unless you have a calculator that can calculate these guys, then it's very easy. But if you can't, then you just have to do a couple of manual multiplications, which are not so bad, and recognize that this pattern exists where you get zeros as the last few digits, and therefore the sum will always be 437 like that, and therefore the position will be 7 because you're just dividing by 10 and taking the remainder. So 7 is the answer to this question. Therefore, number 25, it is choice D.